All right, so in the last video we talked about this formula, and we didn't prove it, but we kind of talked about where it came from and why it is what it is. Um, so, okay, so let's just do an example. Well, first let me just show you guys how to calculate this binomial coefficient. If I want to calculate, so up here we did 5 choose 2. Let's just calculate 5 choose 2 a couple different ways. I said there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different combinations. I hope that's right. I might have forgotten some because, let's see if this formula gives it to us. So n is 5, so that's 5 factorial over k factorial is 2 factorial, and then this is 5 minus 2, or 3 factorial. So this is 5 times 4, 4 times 3 times 2 times 1. That's what factorial means, if you recall. 2 times 1, and this is 3 times 2 times 1. So 3, 2, 1 cancel. This 2 cancels with this 2 of those, so you get 10. Okay, so I must have counted them all up correctly. I didn't miss any. I didn't forget any. Yay me. Now, your calculator can do combinations as well, of course. It's in the probability menu, probability, and you can see the third option down. There's factorial, by the way. Permutations, if you remember, those are when you're choosing two things. You want to take 4 things out of 10 and then not just find how many combinations of those 4 things, but how many different orders you can put those 4 things in. But who cares? We're going to go to combinations. 5, 2. So it says n choose r, but then you got to put the 5, 2 in the parentheses, and it gives you the 10. Okay? So the calculator can do it. We can do it by hand. This is not a formula you're given, but I'm going to show you here in a little bit. It's not a formula you really need either. Okay? Okay, so there is a calculator shortcut to use this entire thing. If you don't want to do it by hand, or you don't want to do it to calculator, just type in the formula. There is a shortcut, just like there's a normal CDF. The shortcut to find the probability that x is equal to 1 value is the binomial PDF. So I know this is going to be a little bit confusing because we never use the PDF for the normal, but here we do. So the binomial PDF, you put in the number of trials, comma, the probability of success, comma, and then x is the number of successes you want to calculate the probability of. That will do this formula for you. Okay? Okay, so let's do this. Suppose a basketball player makes 0.6 of his free throws, and suppose each free throw is independent of the others. She attempts 10 free throws. Let x equal the number of shots she makes in 10. Find the probability that x is equal to 6. Find the probability she makes exactly 6 shots in 10. Okay, so let's use the formula. I don't know why I put that way over here. I know why I put it over here a little bit, but first, do we have a binomial setting? We're checking the bins. Binary, she either makes it or she doesn't. Independent, they said it was independent. Set number of trials. Probability of success is the same on each shot. Looks like we're good. So binomial, that gets me 1 point. 2, number of trials is 10. 3, the probability of success is 0.6. I can't emphasize this enough. You need to have this somewhere on your paper. NP and the word binomial. All right, so if I want to calculate the probability of getting exactly 6, 10 trials, I'm going to put it into this formula. That is 10 choose 6 times the probability of a success, 0.6, to the k power. This is k. That's the number of successes. So she makes 0.6% of her shots. We want 6 successes, so she's got to make. That's 0.6 to the 6th. And if she makes 6 shots, she needs to miss the complement of 0.6. She needs to miss 4 shots, 10 minus 6. So there we go. It's really easy to use. To type in our calculator. Now, I could put in this formula, right? 10 factorial over 6 factorial, 4 factorial. I could use this for this, but calculator can do it, so let's just use the calculator. Menu, probability, combinations, 10, choose 6, times the probability of a success, 0.6, and how many successes does she make? She makes 6 shots. Get over there, stupid thing. Times the probability of a failure, 0.4, and she misses 4 shots. So apparently there's a 25.1% chance that she makes exactly 6 shots out of 10. Okay? Now, our calculator did this for us. It's not that hard. I used the formula, but here's the thing, you don't even have to use the formula. If you set all of this up, you can just put the binomial PDF in it doesn't even feel right, like you should do this, right? But this is actually gets you credit for your work. So if you have this and you have this, you could just put this in your calculator. Let's try it. Menu, statistics, distributions, binomial PDF. It even tells you what to put in. Number of trials, 10. Success, 0.6. It says X is optional here. I wonder what that means. This is the number of successes, so that's going to be 6. And you can see it gives us the exact same thing. So this really makes it easy. I kind of would encourage you to do this, but you know, whatever, I don't care. This and this and this, you're okay. It said that last input was optional. I wonder what happens if you don't put that in. I already know what happens, but I'm just... So if you don't put in the last input, it'll actually calculate all of the probabilities. If you don't put in the number of successes, it'll do 0. So the probability you don't make any shots is this. This is a probability you make 1, 2, 3, 4, 5. Actually, there's 6. That's the one that we wanted up here. This actually does 7, 8, 9, and all the way up to the top, which is 10. So this will actually calculate all the probabilities, basically the probability distribution. Create a table of the probability distribution or probability for model for X and graph it. So here they're asking us to graph it, to calculate all those probabilities. Actually, I just calculated them all here and graph it. But I'm going to try to use the calculator to a little more efficiently here. So I'm going to put in all my outcomes, call them XXX. The lowest number of successes she could have is 0, or she could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the different outcomes. Those are the different number of shots she could make. So now I got to calculate the probability of each of these. So I want to put in the formula. I'm going to put in X. So you could actually, well, I guess I'll do it this way. We'll go statistics. Sorry, let's get the function menu. Looks a little different when we're in the graphing, but you just go to statistics. Distributions is still there for us. Binomial PDF, 10 trials, 0.6 success. And then for my X values, I actually want to put in the list XXX. So it's going to grab the probabilities for each of these. If I go down to 6, I should get the, oh, come on, the 0.251. So those are the probabilities. Let's graph it. Put in your X's. Remember, don't just hit this. It makes a scatter plot. You go to Menu, Plot Properties, add a Y summary list. Put in your probabilities. There's our first picture of a binomial distribution. Does it look a little bit familiar? Nice and mound-shaped, unimodal. Yep, that's not necessarily a coincidence. So, okay. You can graph that here if you want. I just wanted you to do it in the calculator. Find the probability that he makes at least 5 free throws. So this was my model. He could make 0, 1, 2, 4, 5, 6, or as many as 10. If I want the probability he makes at least 5 free throws, that is 5 or more free throws, that would be these all added together. I'd have to add this one, this one, this one, all of those. So this is a bit of a pain. You know, I'd have to run this command for 5, 6, 7, 8, 9, and 10 and add them all up. Or I'd have to take, you know, whichever ones, you know, are in this list, right? So there is a shortcut for that. And I will show that to you in the next video, okay?